Okay, now it's time for Trig Identities Day 3. Here are some other techniques that you will need to incorporate when simplifying trig identities. So let's just take a trip for a second down back the road to elementary, where we started learning how to add and subtract fractions. And so in the basics of adding 2/3 plus 1/4, we needed to find a common denominator. Okay, let me try that over again. Hold on. Needed to find a common denominator. And in this case, our denominator values were not the same. So what we would do is we would go find a least common multiple. In this case, the least common multiple is a 12, so that both denominators would end up being the same. So in order to do that, we would take the first fraction, 2/3, and in order to convert the 3 into a 12, we would multiply top and bottom by a 4, because in essence what you're doing is multiplying 4 over 4, which is a 1, and when you multiply by a 1, you aren't changing the value of the fraction in of itself. 1/4, we are going to multiply numerator and denominator by 3, and in so doing what we achieve is that your denominator for the first fraction turned to a 12, and the denominator for the second fraction turned to a 12. So when you combine these, you end up with 11/12. Okay, so this technique does not change just because all of a sudden you're working with trig functions. Okay, so if you notice here in part B, we have a denominator value of cosine theta and sine theta. Those are two distinct numerical values. Okay, so what we want to do is get those denominator values to be common so that we can combine these fractions. So using the same method of approach that we did in part A, let us go ahead and do it here for this one. So 1 over cosine, what I want to do is obtain a common denominator. So I'm going to take 1 over cosine theta, and I'm going to multiply top and bottom by the other denominator of sine theta. Okay, so I'm going to multiply top and bottom by sine of theta, and again, when I'm doing this, I'm actually multiplying by 1, because sine theta over sine theta is a 1. And then I'm going to add 1 over sine theta. Sorry, my pen is giving a little trouble here. 1 over sine theta. And I'm going to also multiply it, top and bottom, by the other denominator, which in this case was cosine theta. Okay, so notice now the first denominator is cosine sine, the second denominator is sine cosine, and so these are both the same value in the denominator. So we are able to combine these, multiply the numerator values of 1 times sine, and that just ends up being sine theta, and multiply the numerators 1 times cosine, I need to put the plus, cosine theta, and I can put the answers over the common denominator, and whether you write cosine theta times sine or sine theta times cosine, it does not matter. And that right there is where you will stop once you combined your fractions into 1. Okay? So let's try the next one. 1 over 1 minus cosine plus 1 over 1 plus cosine. So just because the denominator values this time have more than one term, adding and subtracting, what I want you to visualize is that these terms go together. So there's actually like invisible parentheses that go around those, okay? So the technique is still going to be the same. Don't change anything as far as the approach. So here we go. I'm going to write the 1 over the 1 minus cosine. I'm going to go ahead and put parentheses around it. 1 over cosine theta. And let's multiply top and bottom by the other denominator, which was 1 plus cosine theta. Let's put parentheses, 1 plus cosine theta, and the parentheses is just to remind us that those go together. And then we're going to do plus, write the other denominator, 1 plus cosine theta, and put the numerator of 1, and I need to multiply top and bottom by the other denominator of the first rational, and it's going to be 1 minus cosine theta over 1 minus cosine theta. So these things that are written in red are all ones, so we are not changing the problem, because when you multiply by 1, you're not changing anything. Okay, so this 1 needs to distribute to that 1 and to this cosine. So 1 times 1 is just a 1. 1 times cosine is positive cosine theta. And I also need to distribute this and this. And it's going to also be a positive 1 and a minus cosine theta. And all of that has to be divided by the common denominator of 1 minus cosine theta times 1 plus cosine theta. So that's going to reduce to 1 plus 1 is a 2. And notice that the positive cosine theta and the negative cosine theta become 0. So those disappear. Now, I do want you to realize that these here are conjugates, right? And we already learned in the previous section that when you have an A minus B times an A plus B situation, whoops, let me make sure that's actually an A plus B situation, that our answer will always be A squared minus B squared, or vice versa. So when these are conjugates, you can just simplify. Well, 1 squared is just a 1, and cosine squared is cosine squared, and so I don't have to FOIL or distribute first, outer, inner, last to simplify. Okay? Now, go look at your chart, your formula chart, and you're going to realize that this actually is a trig identity. 1 minus cosine squared is equal to what? So if you go look at that, you should be seeing that it is equal to sine squared theta. Okay? But we know that 2 over sine squared theta, that's actually the same thing as saying 2 times 1 over sine squared theta. And the reason I'm writing it this way is to help you see more clearly, because this right here, 1 over sine squared theta, is actually cosecant squared theta. Okay, so 2 over sine squared theta is the same thing as 2 cosecant squared theta. That is the final answer of the combination of the two fractions we started out with. Okay, alrighty, let's go to part D. So part D is tangent theta minus secant squared theta over tangent theta. So I'm going to actually come over here to the right, since I kind of used up some space there, and I'm going to write it over. Okay, so in this case right here, what we're going to want to do is get common denominators. Now, the first term, tangent theta, is not a fraction, but what I'm going to do is I'm going to put a over 1 so that it looks like a fraction right off the bat. And now I'm able to do what I was doing earlier of writing the given problem and multiplying it by the other fraction denominator. Take that denominator and multiply it top and bottom. And then I need to write the minus secant squared theta all over tangent theta. And I need to multiply it top and bottom by the other denominator, which was just a 1. And I don't really have to write the 1, but just to make you see that it's consistently the same process, I'm going to go ahead and write it in. Tangent times tangent is tangent squared theta. So now I'm seeing about all the numerator values. I'm distributing them out. Minus secant squared theta over the common denominator of 1 times tangent theta, which is just tangent theta. Okay, so this numerator right here, okay, should send us messages to go look at our formula chart, okay? So tangent squared minus secant squared, let's see if there's a way of simplifying it. So if we go to our formula chart, okay, we'll notice here in this row right here, this is our tangent and secant squared row, but none of these has tangent squared minus secant squared. Okay, we have 1 plus tangent squared, we have secant squared theta minus 1, we have 1 minus secant squared theta, but none of these are manipulated to where we see tangent squared minus secant squared theta. So you need to pick one of these to manipulate, and honestly this one here is the easiest to manipulate. Tangent squared equals secant squared theta minus 1. So let's go ahead and bring this over to our paper. Tangent squared equals secant squared theta minus 1. And so I'm going to shift this over a little. Let me make sure I have the right cursor. So let's see here. Stand by. Okay, so I wrote it in this pink box. So we need to manipulate tangent squared equals secant squared theta minus 1. We want to make it look like this. Tangent squared minus secant squared. So what I'm going to do is I'm going to subtract secant squared on both sides of this equation that's in my chart so that I can obtain the desired tangent squared minus secant squared. Because tangent squared minus secant squared, I'm going to write it horizontally because that's what I'm seeking. And I'm going to figure out exactly that it is equal to -1. Because that's the only thing left on the other side because the secant squared and the secant squared zero out. So since tangent squared minus secant squared is equal to -1, I can come up here and replace my numerator with a -1 over tangent theta. And -1 over tangent theta is just going to be negative cotangent theta. And that's my final answer for this problem. So sometimes be aware that you are able to manipulate the formulas that are in the chart as well. Let us cross out F because that was just a previous problem we've already covered. Let us now do this last problem. So tangent theta over cotangent theta plus 1. So here is another example where you're going to be tempted to do the following, and you can, it's not wrong. You're going to be tempted to say, okay, tangent theta over cotangent theta plus 1 over 1 and attempt to get the common denominators. But I want you to slow down in doing so, because here's what I want you to realize. Tangent theta is the reciprocal of cotangent theta. All right, they're related. When you have reciprocals that are written above one another, you can go ahead and bring them together into one term. So how do you do that? Well, whether you change the tangent or the cotangent, it doesn't matter. So in other words, you can change tangent to be in terms of cotangent or cotangent in terms of tangent. So let's just do, again, it doesn't matter, okay? So I'm going to draw my division line. I'm going to keep the tangent theta, and I'm going to rewrite cotangent as 1 over tangent. Okay? Again, you could have chosen the other way. Ultimately, the answer is going to come out to be the same if your arithmetic is correct, okay? And then I'll put that plus 1. All right? So notice in this problem, all I did was substitute cotangent theta as 1 over tangent. So now I have this stacked fraction, this complex fraction, where I could keep, change, flip, which I prefer you guys say multiply by the reciprocal, but I know those little catchphrases help you guys. So keep the tangent theta, multiply by the reciprocal of 1 over tangent, which becomes tangent theta over 1, or just tangent theta, plus 1. But tangent times tangent is tangent squared theta, plus 1. And tangent squared theta plus 1 is what? Well, if you come over here, tangent squared theta plus 1 is this one right here on the second to last row. It is replaced by secant squared theta. So secant squared theta. And that's our final answer. Very quickly, what I'm going to do is show you that instead of replacing cotangent, if I replaced tangent with 1 over cotangent and done the other way, right? So 1 over cotangent theta over cotangent theta, and then here's the plus 1. You still have the keep, change, flip here, so 1 over cotangent theta times the reciprocal of cotangent is 1 over cotangent plus 1. Well, 1 over cotangent times 1 over cotangent, that is just 1 over cotangent squared. Theta plus 1. But 1 over cotangent squared is what? That is just tan squared theta plus 1. And as we have already established, tan squared theta plus 1 is secant squared theta. So again, it does not matter what direction you decide to change. That's it. I think that's a wrap. So adding and subtracting fractions when it involves trig functions, hopefully you have realized the rules are still the same. Thanks for watching.